In this video we'll look at choosing the sample size for a proportion. This is exercise 8E.2 in our text. So as we have seen before, the confidence interval for proportion, we have the typical adding 1.96 lots of the deviation on root n, and then minus 1.96, etc. So the confidence interval as drawn here, we have the width is the distance between one extreme and the other, which in fact turns out to be twice the distance from the population proportion to this value here, which works out to be 2 lots of 1.96 times by root p1 take p on n. A thing to remember here is that the width will be a percentage, and therefore if we were to say 4%, we'd enter 0.04, not the actual number 4, so be careful with W. Now when we work with the sample size for a confidence interval of a mean, then we had some value for the standard deviation. In the case of our proportions here, we need to know something about the possible value of p hat for the sample proportion. So there are two cases. First case, we are given a value for the sample proportion, and here we have p star in our formula in place of p hat. Now if you rearrange this formula up here, we'd end up with this equation down here for n, which is similar to the formula we saw back in chapter 7. So all we need to do is replace our sample proportion, or the estimate for it, and our width to work out the sample size. So in our example, a medical procedure is successful in 80% of the patients treated. The new procedure is being tried. We want a 95% confidence interval with a width of 4% to estimate the chance of success of the new procedure. Right, so first up, this value of 80% is our estimated value for the proportion. So we have 0.8 there. Now, our width here is 4%. Now, as I said previously, 4%, we would not enter 4, we would enter 0.04. So here's our formula for the number of patients, the sample size. So all we have to do is replace W and P star. So 0.04 here. And then our estimate for the proportion is 0.8. And therefore 1 take away 0.8 would be 0.2. So we end up with about 1537 for our sample size. Now, case 2, we have no value for the sample proportion. So what we do is we look at the fact that the sample proportion multiplied by 1 take the sample proportion is in fact quadratic in form. So consider f of x equals x times by 1 take x. We get this quadratic here, and as we know, that quadratic is upside down, and therefore it has a maximum value. The vertex, look here at minus b on 2a, so minus 1 on minus 2. So this expression here, being quadratic in form, we have a maximum value of a quarter. If we replaced x equals a half, and a half here, we'll get a half times by a half, which is a quarter. And that occurs when the sample proportion is a half. So even if we have no information about the sample proportion, we can find a minimum value for the sample size by allowing our proportion to equal a half. And this formula here you can see hasn't changed at all. So next example, we have an experimenter wishes to estimate with a probability of 95% the proportion to within 3% of mosquitoes which carry a virus. So once again, how large must the sample be? So we're working at the 95% level. So here's our formula once again. So in this case, we would need to replace the value of W by, now, if we're within 3%, that's 3% either side. So the width would be 6%, so 0.06 would be a value for W. And we are not given the sample proportion, so therefore we can estimate it to be a half, 0.5. So therefore, our sample size, N, we replace our values into the formula. So the 0.6, the width, 0.5, and then 1 take 0.5. So we end up with the number being approximately 1,067. And just as a note, we don't always use 0.5 as an approximation in all problems, because if we are a long way away from 0.5 as our proportion, then our sample size will be unnecessarily too large. So only do this if you don't have the sample proportion provided. And you'll find these sorts of problems in exercise 8E.2. Now 8E.2 looks at assessing claims with confidence intervals. So for example, a nutrition expert found 43% of Victorian children ate insufficient fruit each day. To check whether this figure was the same for South Australia, a university research group sampled 625 children and found 308 ate insufficient fruit each day. For part A, find the 95% confidence interval for the proportion of South Australian children eating insufficient fruit. So we have our proportion given to us, our sample proportion. We would have 308 out of 625. So we have 0.4928 is our sample proportion. Then all we would have to do is go to the calculator in stats mode, and we would enter in our values for X and N, and we'd end up with our population proportion being between 45.4% and 53.2%. Now part B, how does the proportion of children not eating enough fruit in South Australia compare with that of Victorian children? We've seen that 43% of Victorian children are not eating enough fruit. So as the proportion is 0.3 of Victorian children, that is not in the interval, it is outside of that lower limit there. There is evidence that the proportion of South Australian children who eat insufficient fruit is different from those of Victorian children. And that's what you'll find in exercise 8E.4.